Hi and greetings to Dr. Rodney. We are from Group 14. In this video, we will be talking about physics in everyday life, and we will explore how physics applies in biotechnology and mathematics computer graphics. My group member consists of me, Nushra Afira binti Muhammad Saleh, Ain Chuhada binti Saidin, Vivian Ferdifu, and Irene Chin Chuan Yen. So let's jump straight right in. Let's start with some basic concept of what is biotechnology and mathematical computer graphics are. So biotechnology is a multidisciplinary technological branch of science that encompasses basic science such as physics, biology, and chemistry. In this video, we'll be looking into the law of thermodynamics and how it contributes to fermentations, and thermophysics and how it contributes to hypothermia therapy. While physics play a huge role in biotechnology, it also enhances mathematical computer graphics by providing principles to simulate real-world behavior and motion, ensuring visual are both appealing and realistic. In this video, we're looking into how solid represent 3D objects by looking into boundary representation and constructive solid geometry, and also how physics contribute in fluid by using Navier-Stokes equation for fluid simulation, Eulerian methods, Lagrange methods, and hybrid methods.
Solids in mathematics refer to a three-dimensional geometric object with volumes and boundaries. A mathematical solid defined by equation formula for sphere, which is x squared plus y squared plus z squared equal r squared, or a polyhedra like cube, tetrahedron, sphere, and etc. Solids in computer graphics represents 3D objects with well-defined interior, exterior, and boundaries. Method includes boundary representation, which is BREP, and constructive solid geometry, which is CSG. Solids are rendered as static objects or deformable entities in simulation. Fluid in mathematics is the study of fluid dynamics, which is the behavior of liquids and gases, modeled using Navier-Stokes equation, which is partial differential equation governing fluid motion, and vector field, which is described velocity, pressure, and flow of the fluid. Fluid in computer graphics used to create realistic animations of liquids, gases, and other flowing materials. Techniques include Eulerian methods, Lagrangian methods, and hybrid methods. Fluid in computer graphics were very much needed in order to create a realistic effects in video games, visual effect, physics-based rendering, and real-time simulation.
Did you know that energy is never lost? It's just transformed. Let's see how this concept powers biotechnological process like fermentation. I will explain how the first law of thermodynamics applies to fermentation process. In fermentation, glucose serves as the starting energy source for microorganisms like yeast. The process begins with glycolysis, where glucose breaks down into pyruvate and releasing a small amount of energy in the form of ATP. When oxygen is absent, fermentation continues and pyruvate is converted into ethanol and carbon dioxide, thus releasing more energy. However, much of the energy in the glucose is not captured as ATP, but it's stored in ethanol or released as heat. This entire process follows the first law of thermodynamics, which states that energy cannot be created or destroyed, only transformed. The energy in glucose is transformed into ATP, ethanol, and heat, demonstrating how energy is conserved but changes, but throughout the process, even if some energy is less useful for the cell.
The last part is about the thermal physics. The subtopic they chose is temperature and thermometer. So, how temperature applies in biotechnology? One of the applications is hyperthermia therapy. What is hyperthermia means? Hyper means excited or high, while thermia means temperature. So the complete meaning of hyperthermia therapy is high temperature therapy. What does this hyperthermia therapy do? It is the use of high temperature to kill the cancer cell with little or no damage to other normal cells. So, how hyperthermia therapy is given? During treatment, the doctor numbs the treatment area and inserts small probes with tiny thermometers into the tumor. Thermometers help the doctor closely watch the temperature of the tumor and nearby tissue during treatment. These are the type of hyperthermia treatment, which is local hyperthermia, regional hyperthermia, and whole body hyperthermia. Local hyperthermia only includes small part of the body like epidermis tissue on hands, while regional hyperthermia includes large area of the body such as organ or peritoneal cavity. Last but not least, whole body hyperthermia. It is to treat the cancer that has spread throughout the body. The patient will be placed in a thermal chamber or wrapped in hot water blanket.
The synergy between physics, biotechnology, and mathematical computer graphics drive numerous modern innovations. This convergence fosters groundbreaking advancement in medicine, bioengineering, and data visualization, ensuring continued progress in science and technology. That's all from Group 14. Thank you.